This is Chapter 10, Section 3, Arcs and Chords. Scan the lesson 10.3. List two headings you would use to make an outline of this lesson. So if I look in the book, there are two specific headings throughout this one. First one is just simple, what is an arc and a chord? So we'll say arcs and chords. And the second one is talking about bisecting. So we will say bisecting arcs and chords. In the circle provided, draw a chord, which is not the diameter, using a regular line, a diameter using a heavy line, and a radius using the dashed line. Identify the three arcs that were created on this circle. So they actually did this for you. A little bit of a mistake here in the notes, but how about we list out each of them? So I see that FE is that chord because it goes from one side of the circle to the other. I also notice that DB is a chord, but more specifically, it's the diameter. And last, I notice that I have this dashed line. Let's name this center O. So we'll say OC is a radius, but if I wanted to list all the radii, I see OC, OB, and OD are actually all radii in this case. So it wants me to identify three of the arcs. Now there's definitely more than three arcs in this circle, but I could say arc FE, arc EB, arc BCD, arc FDC. There's a lot of different names or a lot of different arcs in this circle, but there's just a few of them. If you had one that was a little bit different, that's okay too. So here's starting with our examples. This is actually more specifically on page 715. 701, 702 has some information, but 715 has a little bit more if you're looking for additional examples. So if I look at this, PO and MN are congruent, and I know that because it has these little dash marks on it to show me that they are congruent. As you move closer to the middle of the circle, as you move closer to Q, your chord is going to get bigger, where the biggest chord would then be the diameter. As you move farther away from the center of the circle, the chords get smaller because you're moving farther from the center. Now these chords are exactly the same, meaning they are the same distance from the center, so that's just something to note. It says use the definition of congruence to write an equation. Well, if these two are congruent, another way to say that is these two are equal. So I can solve for x. I can subtract 3x from both sides, and I can add 9. Divide by 2, I find x is 8. So if I wanted to plug it back in, I really only have to plug it back in once, because when I plug it into one equation, it's going to be the same for both since I know that they're congruent. So I'm going to come over here so I have a little bit more room. I say 5x minus 9 is PO, and I just found I found x to be 8, excuse me. I'll do 5 times 8 minus 9 to find that PO is 31. Now if you wanted to plug it back in, you could plug it into 3x plus 7, but you're also going to find that it is 31. Therefore, if the chords that cuts the arc are congruent, I can then say that this portion of the circle and this portion of the circle are congruent. So arc PO and arc MN are congruent arcs. Because they're cut off by congruent chords. So the next thing you see is it's talking about bisecting. We learned about bisecting at the beginning of the year. We know that bi means two and sect means to cut. So we are cutting the arcs or the chords into two equal pieces. These theorems are both on page 716. It says in the diagram, state the theorems 10.3 and 10.4 from your book in your own words. It's going to be a little bit easier if we can name this point where they intersect here. Well, let's name this O. So I'm going to rewrite theorem 10.3 and 10.4. My suggestion would be to head to that page 716, maybe pause the video and read through those theorems first, and then come back and rewrite these with me. So theorem 10.3, let's start out with what the diameter is. Well, the diameter of this circle is AB. So I'm going to say AB is the diameter of the circle. Okay, and now I have to define what is NP then. Well, NP is just another chord. So theorem 10.3 starts out with the diameter and a chord. So now we can say AB is the perpendicular bisector of NP. So, a couple things to note. We already said bisector, bi means two, sect means to cut. So if I look here, it's cut into two equal pieces. Remember that word perpendicular means it forms a right angle. Just a little bit of review there. Okay, so now let's go to theorem 10.4. 10.4 would start off with NO and OP being congruent. So now I'm going to say, since the two pieces that are bisected, NO is congruent to OP, AB is the perpendicular bisector then I can say that that means AB has to be the diameter of the circle. So why might this be useful? Well, you're going to see a lot of problems here where they might form a triangle like this. Now that's something you can solve because we know that the Pythagorean theorem would give me a squared plus b squared equals c squared. That might be useful because I could write something like QO squared plus OP squared equals QP squared. I can use that Pythagorean theorem. I also noticed that by drawing QP, QP is another radius. So if they give me the radius of the circle, I would be able to use this in a problem. That's just an example of one of the types of problems you might see in this practice. So the last part of this lesson is talking about theorem 10.5, which theorem 10.5 is just on that very next page. So I would probably do the same thing, pause that video, look at theorem 10.5, and then let's come back and write it in our own words. So theorem 10.5 starts with two chords being congruent. So I would say something like, if you have two congruent chords, then it's talking about something that's perpendicular to the first chord. And you draw a segment perpendicular to the first with the center as an endpoint. Then I can make this statement that it will be equal to the segment perpendicular to the second chord to the center. And again, they have a nice picture drawn out there if you would like to copy it on your notes as well. So again, over and over and over again, we're going to see things that are congruent. So remember, congruent means equal. As you move closer to the middle of the circle, your chord gets bigger until it's the biggest with the diameter. As you get further away from the center of the circle, your chords get smaller. But if they're the same distance from that center, we know that they're going to be equal. So that's the end of 10.3. Thanks so much.